Vertical angle theorem states that vertical angles are congruent. So in problem 1, yes sir?
I'm sorry to fall asleep. Can I get a drink before I fall asleep?
I appreciate that. Yeah, take it fast. So in problem 1, very straightforward, just solve for x. So what's my equation then in problem 1? What's my equation for problem 1? Kristen?
Would you do 2x plus 36 equals 3x minus 10? For problem 1. I mean, 2. What? 42.
It's all right.
I know why I said that.
2x plus 42, yes. Equals 3x minus 10.
No, I saw 36.
Stranger things have happened. It's all right. Her heart was in the right place, and that's what matters. Okay, from here, the equation solving process is easy. You're subtracting the 2x from both sides and adding 10 to both sides. Always, always, always go back, look at the question, see if there's more that you need to do. In this particular instance, there isn't. That is like the ugliest 52 ever. Since the question was simply asking us for the value of x, we are in fact done. Very quickly, I'm sure within your group you would have no trouble addressing the your turn problem 1 along the same lines. So what is the value of x in the your turn for problem 1?
40.
It's 40. Your equation gets set up just the same way. The your turn for problem 1, your equation would be 3x equals 2x plus 40. And when you subtract the 2x, boom, you've got x equals 40. In problem 2, you see that we are starting to do proofs from scratch. I've given you a big hint in indicating on the screen that this proof only has 4 steps. As I've said before, 99.9% of the time, we start with our given, and that's where we start with this one. So we have, in statement 1, that angle 2 is congruent to angle 3. And what you'll hear me often say when we are doing these proofs is that you want to start with your given and run with it as far as you can go. And as it turns out, there's not so far I can run with just angle 2 congruent to angle 3. And then the next thing that I'll tell you about doing proofs is after you've run as far as you can with the given, not from the given, then you come back to the diagram. And you look at the diagram and you look at what you have and you look at where you're trying to go and you see what connections the diagram allows you to make between what you have and what you're trying to prove. So I have that angle 2 is congruent to angle 3. I want to prove that angle 1 is congruent to angle 2. So what I'm looking for is some way to bring angle 1 into the picture. What can I say about angle 1 that's going to get me closer to saying that angle 1 is congruent to angle 2? Yes?
Angle 1 is congruent to angle 4.
I cannot make that assumption. Even though they look like they are, you can't do that.
Angle 3 is congruent to angle 1. I mean...
Yes. Yes, absolutely. I can say that angle 3 is congruent to angle 1. Why, Maddie?
Because they're vertical.
Yes, they're vertical angles, so what we're using is the vertical angle theorem. So, look, yes, sir?
Now, what you ever do, angle 2 is congruent to angle 4.
You could also say that angle 2 is congruent to angle 4, and you wouldn't be wrong for saying it. However, you'd be saying something that doesn't need to be said for our
So
purposes.
angle 2 is congruent to angle 1.
We can, based on what we've already stated in the proof, yes, say that angle 2 is congruent to angle 1. Benjamin, what is my reason for being able to say that?
Because angle 2 is congruent.
Well, I'm taking previous statements and putting them together, but what I'm asking is, what property am I using to put them all together? No. No. Look back at yesterday's lesson, perhaps. Look at how pretty that flows. Angle 2 is congruent to angle 3. Angle 3 is congruent to angle 1. That was that property that you told us, Mrs. Clouse. It sounds so pretty. It's the transitive.
You said actually
Reject your reality and substitute matter.
Okay, we're using the transitive property in order to say that. Now look at where we are and look at where we're trying to go. Oh!
The symmetric.
Absolutely. In order to flip that congruent statement around to say exactly what I'm trying to prove, yes, we are saying angle 1 is congruent to angle 2 by using the symmetric property. To make sure that I'm clear, some of you might be looking at that congruence sign and wondering, why do I need to write that? It's a good habit to be in to distinguish between just the symmetric property and the symmetric property of congruence. To clarify on the difference between those two. The symmetric property has an equal sign, whereas the symmetric property of congruence has a congruent sign. That's it. There's our first geometric proof. Okay? On the back, you will see that there are many, many other theorems that you're getting in today's lesson. Let's talk about a few of them. I'm going to kind of jump around a little bit. The theorem out of that group of them that we end up using the most, if you're looking at the back of our notes, is it on the back? Yes.
So
Okay.
from 2.
Oh, my bad. So, in the back of those notes where we're looking at all of those theorems, the one that we end up using the most, if you wanted to know that, would be all right angles are congruent. We'll end up using that very frequently when we get to chapter 4 and we're proving triangles congruent, which is our big, massive proofs chapter. Now we're just kind of dipping our toes in the water. In chapter 4, that's where it's big time, where we're proving stuff a lot.
Was it actually the combination course exam a lot last year?
Proofs, I think there was probably a few examples on there where you're kind of, and again, remember, it's a multiple choice question, so you'd be able to kind of pick a property out of the crowd. And as long as you can do that, you should be fine. The other 3 properties on the screen, we might use them occasionally, but nowhere near as much as the all right angles are congruent. For the congruent supplements theorem, it's kind of wordy and maybe it's kind of weird to understand what they're trying to get across. Here's what they're trying to get across. If I have, let's say, 2 supplementary angles, 1 and 2, and I have this other angle, angle 3. If I know visually, based on the example I've given you, it's very clear that angles 1 and 2 are supplementary. If I also told you that angles 1 and 3 are supplementary, notice if angles 1 and 2 are supplementary and 1 and 3 are supplementary, what other property, or what other relationship rather, exists between some angles in this diagram, Taylor?
2 and 3 are supplementary.
Not that they're supplementary, look at them again.
Congruent.
They would be congruent, yes, and that's what the congruent supplements theorem is saying. If two angles are supplement of the same angle, then the two angles are congruent. Congruent complements theorem says basically the same thing, except the angles are complementary to the same angle. Okay, so again, if two angles are complements of the same angle, then the two angles are congruent. And then finally, that last bullet is telling us if two angles are congruent and supplementary, then both angles are right angles. And that should just make sense. Is he still with me back there? Okay. So tell me again what it means to be for two angles to be supplementary. Oh, supplementary. If two angles are supplementary, they add up to 180.
Yeah.
Okay, so if two angles are supplementary and they're adding up to 180, and I know that they're both the same measure, meaning they're congruent, it should just make sense that those two angles are therefore right angles. Okay? The proof format that we use most frequently in this class will be that 2 column. It's nice, neat, very to the point. Occasionally, however, you will be asked for a paragraph proof, or you'll be asked to fill in the blanks for a paragraph proof. And that's the next kind of proof that we'll talk about in today's lesson, just so that you have a heads up. There are other kinds of proofs that we will talk about in this course. We will talk about flowchart proofs later on in this course, and that may feel familiar, especially for those of you that have always done well in science. It'll look like a science flowchart. And finally, the last kind of proof is an indirect proof, but that's closer to like December, bless you. All right, so in problem 3, we are being asked to prove the congruent complements theorem. Are you guys still with me back there? Thank you. Okay, so if I can't see your eyes, or you know, the congruent complements theorem was that second bullet on the back of our notes. We are proving that theorem. Now, even though it's okay for us to use it, and it is a theorem, and it has been proven elsewhere, we are going to prove it. We cannot, therefore, use the congruent complements theorem to prove the congruent complements theorem. That's circular reasoning, and you don't ever want to do that. Since this is a paragraph proof, and my handwriting very frequently leaves much to be desired, I'm going to type this, just also for the purposes of space. In a paragraph proof, just like in a 2-column proof, you start with your given. So let's begin. I am given, we are given, that angle 1 and angle 2 are complementary.
So we just have to write it. We have to write it like a problem.
It's going to be along the same lines as that 2-column proof. You're writing your statements, you're justifying every statement, you're just writing it out like a paragraph. Okay? We are given that angle 1 and angle 2 are complementary, and that angle 2 and angle 3 are complementary. So, that's right, that would be my statement 1. As I said before, when you are doing a proof, you start with your given, and you run with it. This is actually a given that I can run with for a while. What does it mean for 2 angles to be complementary? What does it mean for 2 angles to be complementary?
They have to equal.
They add up to 90, yes. So, by the definition of complementary angles, the measure of angle 1 plus the measure of measure of angle 2 equals 90, and the measure of angle 2 plus the measure of angle 3 equals 90. Now look at those 2 equations. They have something in common. Notice that the right sides of those 2 equations are equal. Oh, I swear I've heard this class use those words before. When the right sides of an equation are equal, what else is true? The right sides are equal. It should make sense, ladies and gentlemen. The left sides will be equal. That means, so the measure of angle 1 plus the measure of angle 2 equals measure of angle 2 plus the measure of angle 3. Realize what I did there. I took those two equations and I condensed them down into one. What property am I using when I do that? When I take two equations and I condense them down into one? Yes, substitution. Kristen, tap him, please. Oh, okay. His head's been... All right, so look at where we are. All right, let's refocus. We're almost done. Let's look at where we are. We have angle 1 plus angle 2 equals angle 2 plus angle 3. Eventually, I want to prove that angle 1 is congruent to angle 3. But darn if that angle 2 just isn't getting in our way. Say it again, Maddie. Take it out by subtraction. We can subtract that angle 2 from both sides. Using subtraction, measure of angle 1 equals the measure of angle 3. And now we're really, really stinking close. We're saying that the measures are equal, but our objective is to show that the angles are congruent. No, this one is a little bit further back. If two angles have the same measure, then the angles are congruent, right? What did I just say? Is that a definition or a property or a postulate? It's the definition of congruent angles, yes. By the definition of congruent angles, angle 1 is congruent. By all means, use the symbol in your notes. I just don't have a congruent sign on my keyboard. Angle 1 is congruent to angle 3. And that's it.
Will you make us write paragraphs on our homework?
Fantastic question. In your homework, there are a couple of paragraph proofs. However, they're fill in the blanks. So, and out of my rare moment of niceness, all I'm expecting is that you tell me what fills in that blank. Okay? Because, of course, I am still expecting that you draw all the diagrams for everything else anyway. Okay.
I'll take that. I'll take that.
Oh, yeah. Because Kristen was doing her homework instead of just strictly taking notes, but that's all right. Okay.